Hello students, welcome to Turning Point classes. In today's session, I will discuss the second level questions of the first chapter of second PUC Physics. Let us start. The given question is two identical charges repel each other with a force equal to 10 milligram weight when they are 0.6 meter apart in air. We are given the value of G. Find the value of each charge. We want to find the magnitude of the charge here. Two identical charges, Q1 is equal to Q2 is equal to Q. That is what given. We have to use Coulomb's law. Simple problem. Use Coulomb's law. F is equal to, straight away we should recall, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. 1 by 4 pi epsilon naught value is known. If you put straight away you can save the time. Q1 is equal to Q2, therefore I write it as Q into Q divided by R square. 1 by 4 pi epsilon naught is 9 into 10 power 9. Q into Q is Q square divided by R square. R is given as 0.6 meter. So 0.6 meter square. F, it is given in the form of milligram weight. Milligram weight. So that is what is the force exerted by 10 milligram. That we have to find out. This will do it outside. F is equal to 10 milligram weight. This is given milligram weight. Sometimes force is expressed in terms of gram weight, kg weight, milligram weight, like this. What we should do is use a formula F is equal to mg, because F should be in terms of Newton. Mass given is 10 milligram. So this is M. M stands for mass. Mass is given as 10 milligram. 10 milli is 10 power minus 3 kg. It becomes. So if you put 10 milligram is replaced by 10 into 10 power minus 3 kg, then G is 9.8. Of course, in our problem it is given as 10. This gives us force. So if you simplify 10 power minus 1, you get here. This is F. Come back and substitute here. 10 power minus 1. Simplify. Rest of things. Don't square this one because Q square is there. Rest of things will send to right side. Q square is equal to 0.6 square. 10 power minus 1 remains in the numerator divided by 9 into 10 power 9. Take square root. Q square becomes Q. 0.6 whole square root, when you find it becomes 0.6. 9 square root when you find, that becomes 3. Bring 10 power 9 to numerator, that becomes 10 power minus 9. 10 power minus 9, 10 power minus 1, that becomes 10 power minus 10. 10 power minus 10 under square root, 10 power minus 10 under square root gives us 10 power minus 5. That's all. Now this is equal to 0.2 into 10 power minus 5 Coulomb. Just if you observe the options, it is given, 4 options are given, just I shift the decimal. 2 into 10 power minus 6 Coulomb. So 2 into 10 power minus 6 Coulomb is nothing but 2 micro Coulomb. That's all. So 2 micro Coulomb is the answer for this question. Come back to the next problem. An alpha particle of mass 6.4 into 10 power minus 27 kg, charge 3.2 into 10 power minus 19 Coulomb is located in the uniform electric field of 1.6 into 10 power 5 volt per meter is given. Initially, the particle is at rest. Find what is the velocity it gained after traveling a distance of 2 into 10 power minus 2 meter. You can compare this problem with first year problems what you learned. By application of a force on a particle or a body has travelled so much of distance. Mass of body is given. Find what is the velocity of the particle after covering a certain distance. Same way here also it is given. That means here we have to use first few equation. Final velocity, initial velocity, displacement. These equations are available to us. Just recall the appropriate equation. So I will take v square is equal to u square plus 2ax. This equation. If you have learnt in terms of x, v square is equal to v naught square plus 2ax. That also you can use it. S stands for displacement. Now let us see. U is given as 0 here. Initial velocity is given as 0, which starts from rest. Therefore, what is the final velocity? V square is equal to 2as. V is equal to root of 2as. That's all. Now, displacement is given. A acceleration is not available. In the previous discussion, I have given how to find acceleration on a charged particle moving in external electric field. F is equal to QE, that is equal to MA. A is equal to QE by M. Substitute that. V is equal to 2. I replace it by QE by M. Yes, everything is under square root. Now we are given the charge of alpha particle. Start substituting. This is equal to 2 into Q is given as 3.2 into 10 power minus 19. E electric field 1.6 into 10 power 5. That is the value of electric field. Then S is given as 2 into 10 power minus 2. Divided by M. M is mass of particle. Mass of particle is given as 6.4 into 10 power minus 27. This is given. So everything is under the square root. Cancellations. 2 into 3.2, 6.4. You cancel with 6.4 in the denominator. That's how it is. Now we'll see. I make this one as 1.6, I make it as 16. When you take fractional values or decimal values, it becomes very difficult for simplification. Make it integer. That will be easier for us to handle. So 1.6 into 2, I make it as 16 into 2. By bringing 110 from here, it becomes 16. 16 into 2 is 32. Only that number will be there. That is under square root. That part I will do it afterwards. So this is 32. Now you bring this minus 27, 10 power minus 27 to the numerator. That becomes 10 power 27 plus 27. Plus 27, here we have 10 power 4 now. Already we have borrowed 10 from here. Therefore it is 10 power 4. 10 power 4. This one is 10 power 27. 4 plus 27 is 31. Now we have minus 19 minus 2. 10 power minus 19, 10 power minus 2. That becomes 10 power minus 21. So 31 minus 21. This gives us 10. 32 into 10 power 10. Everything is under square root. That's all it is. Now this can be written as 16 into 2 under root. Into 10 power 10 under root is nothing but 10 power 5. If you further simplify, root 16 is nothing but 4. 4 root 2 into 10 power 5, that is the answer. So here we find 4 root 2 into 10 power 5 meter per second in option C. So therefore this is the answer for this question. The next question is two identical spheres A and B have positive charges Q1 and Q2. Of course Q1 is not equal to Q2. The spheres are brought in contact and they are placed in their original position. Now we are asked to find out the new force, how it is related with earlier force. So 4 options are given: less than, that, before contact, greater, etc. This type of questions I discussed in the earlier part. Just we have to recall the Coulomb's law as we have done. Quickly we have to do it faster. This is, so F is 1 by 4 pi epsilon naught. I don't take it. F is proportional to Q1 Q2. That is enough for us. So F is proportional to Q1 Q2. This is the initial force before the contact. This is before contact. This also we are not supposed to write in CET as we don't find much time. Because distance is not a factor here, same distance is maintained. This much is enough. Now I have given the previous class one point to remember. The charges on them after contact, Q1 dash is equal to Q2 dash is equal to Q1 plus Q2 by 2. So when two identical spheres charged differently, Q1 and Q2, when they are brought in contact or if they are touched, the charge on either sphere is this. Just to substitute. Now the new force is F dash. proportional to Q1 plus Q2 divided by 2 into Q1 plus Q2 divided by 2. This is what we have. Now we have two equations. So this is equation 1, this is equation 2. Which is greater? That we have to analyze it. Just I will take the f dash only and simplify it. So f dash is proportional to Q1 plus Q2, Q1 plus Q2. Product is there. You can write this one as Q1 plus Q2 whole square divided by 2. Now we can go for a little bit of simplification because numerical values are not given. Just we have to compare these two equations, which is greater. A plus B whole square formula. This gives us Q1 square plus Q2 square plus 2Q1 Q2 divided by 2. This I can split as Q1 square by 2 plus Q2 square by 2 plus, so Q1 square by 2, Q2 square by 2 plus 2Q1 Q2 by 2. That will give us Q1 Q2. Of course, Q1 Q2 I can replace it in mind by F. That means this F dash is equal to, so same constant is there both in equation 1 as well as equation 2. So F dash is much greater than F. Reason being, these are the two additional terms what we come across in the F dash. So therefore, comparing this equation with equation 1, F dash is greater than F. This is the conclusion what we can draw at the end of this equation. We can go for options greater than that before contact. So the option B is the correct answer for this question. The next question is, in uniform electric field E, an electron is accelerated from rest. What is the velocity when it travelled through a distance 2 into 10 power minus 2 meter? So E by m of electron is given. If you remember this value, that will be useful when it is not given in the exam. E by m of electron. Of course, this problem has appeared in Kcet 12. Similar problem I have worked out earlier. In the earlier problem we have seen alpha particle is given. Same method we can do it, very easy. Use first U formula, that is equal to U square plus 2AH. There is a formula what we have. Initial velocity is given as 0. From rest it is given, this part is 0. So therefore this becomes 2AS. So V is equal to 2AS under root. Just we have used earlier problems. F is equal to QE, that is equal to MA. A you replace it. A is nothing but QE by M. Just to substitute. That is equal to 2 QE by M into S under root. Of course, it is electron is given Q by M. We can take it as E by M. Q is replaced by Q is charge. Charge of electron. Standard symbol is E by M into E. So here also you can replace it by E by M. So E is small e, capital A is electric field, M is mass of electron, S is displacement or distance travelled. This is equal to 2 into E by M is given in the problem. Directly we substitute that 1.8 into 10 power 11. This we have to substitute. Then E is left out. E, if you observe in the problem, it is given as 10 power 4. I put that value. Then one more is there, displacement. Displacement is 2 into 10 power minus 2. That also do it. 2 into 10 power minus 2. So this part is under square root. Simplify this. To simplify this, 1.8 I make it as 18. Then this becomes 10 power 10. 18 into 2 is 36. 36 into 2 is 72. Into here left with 10 power 10, 10 power 10, 10 power 4, 10 power 14, 10 power 14, here 10 power minus 2. So 14 minus 2 is 10 power 12. This part is under root. Now 10 power 12 under root is 10 power 6. This is 72. Approximately we have to do it. So if I take 8, 64 under root is 8. If I take 81 under root is 9. Now I am given 72. So it is in between 8 and 9. So I can go for something like, if I glance once, so I am getting something like 8.5 here. So I will put 8.5 into 10 power 6. So therefore option A is answer. Here we are not supposed to go exact value of root 72. Time is not there. Come back to next question. In the next question, we are given a small oil drop of mass mass 10 power minus 6 kg is hanging at rest in, of course, in the electric field, which is provided by two plates. Of course, they should be charged plates where there is a potential difference of 500 volt. Find what is the charge on the drop. So that is the question. Simple one this is. Always weight of a body acts in the downward direction. There should be some force which is acting on a charge drop. That force is now, it is electrostatic in nature. To counter this weight which is acting in the downward direction, there must be some force in the upward direction. So force must act in the upward direction. If force electrostatic force electrostatic. So F is equal to QE must act in the upward direction. So because this is placed in between two plates where there is a potential difference of 500 volt. So ಈಗ ನಾನು ಒಂದು ಡಯಾಗ್ರಾಮ್ ಮಾಡ್ತೀನಿ. So ಇದು potential difference ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದರ ಡಿಸ್ಟೆನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನಮಗೆ. ಡಿಸ್ಟೆನ್ಸ್ ಬಂದು 1 ಮಿಲಿಮೀಟರ್. 1 millimeter is the distance. Of course, there is a potential difference of 500 volt is given. So, this is HK discuss madala. Negative charge are one direction electric field. Positive charge are in one direction electric field direction. 1 mm is the distance between these two plates where there exists a potential difference of 500 volt. So, think of these two plates as the plates of capacitor, which is there in second chapter. Is to solve. Since the oil drop is stationary, these two forces must be in opposite direction, they must be equal in magnitude. That much is enough. Now if I take QE is equal to mg, I want to find Q is equal to mg by E. ನಮಗೆ E ಕೊಟ್ಟಿಲ್ಲ, but we learned in second chapter E is equal to minus delta V by delta x on derivation ಇರಬಹುದು. ಇದೆ. This is also equal to minus dV by dx. In some colleges or places they might have done like this. In words, if I take E is equal to minus times potential difference divided by distance. I use this equation. Of course, if I drop negative sign, magnitude alone if I take, then I can write this equation as Q is equal to mg. Retain ಮಾಡಿ E na replace ಮಾಡಿ. Potential difference we can take it as V divided by D. ಇಲ್ಲಿ V ಬರುತ್ತೆ divided by D ಬರುತ್ತೆ. That goes to numerator. Now substitute the given values. M ಬಂದು ನಮಗೆ 10 power minus 6 kg that is given. G is of course it is 10. D is the distance. So D is the distance between two plates. It is given as 1 millimeter. 1 milli ಅಂದರೆ 10 power minus 3 divided by V potential difference 500. Simplify ಮಾಡಬೇಕು ಅಷ್ಟೇ. This is equal to 1 0 cancel ಮಾಡಿ. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾರೆ ಇದು 1/15 1/50 ಬೇಕಾದ್ರೆ ಮಾಡ್ಕೋಬಹುದು. ಕ್ವಿಕ್ ಆಗಿ ಮಾಡಬೇಕಂದ್ರೆ 1/5 ತಗೊಳ್ಳಿ. ಇಲ್ಲೊಂದು 10 ಇರುತ್ತೆ. 10 you bring it up, it becomes 10 power minus 1. 10 power minus 1, 10 power minus 6, 10 power minus 3 ಇವೆಲ್ಲ ಆಡ್ ಮಾಡಿದ್ರೆ you will get 10 power minus 10 power minus 6, 10 power minus 3, 10 power minus 1. If you add all these things, you will get 10 power minus 10 divided by 5. So 1/5 I write as 0.2. Easy to calculate 1/5. 1/5 is 0.2 into 10 power minus 10. If you observe the given options, it is not there. Just to quickly you can write this one as shift the decimal by one place towards right. That gives us 2 into, now this number becomes minus 11. So 2 into 10 power minus 11 is the answer for this question, which is available in option. So today's session I will end. So if you are not subscribed to the channel, subscribe to Turning Point Classes. Share the video with your friends. Like the video. I will come back with few more questions in the next session. God bless you.